Okay, so go ahead and you can pick any one you want.
Right.
Which eigenvalue? Well, actually, don't pick 0 because then that doesn't change the matrix at all.
Alright, let's do this one here.
Okay.
So our matrix is going to become. I'm going to write it up here.
Yeah, hold on. Let me move the camera up there.
So we get.
And then let me turn off this dining room light. But go ahead, keep talking.
So we're gonna subtract lambda away from these three values. So this turns into -2, 1, -1, 1, 0, 1, and -1, 1, 0.
Okay.
And then we have to multiply this by a vector x1, x2, x3, which will eventually become the eigenvector to get 0, 0, 0.
Okay.
So what we do is we can row reduce this matrix and it'll still leave us with the same eigenvector. So what we want to do first is obviously get the second row.
Here, yeah.
Right.
So maybe we will erase this, and so you can work down and still stay on camera.
So we're gonna subtract half the first row away from the second row, or add half the first row to the second row because of the -2. So it's -2, 1, -1. Then we have 0, 0.5, and 0.5. And then -1, 1, 0. And then we're gonna instead subtract. We're gonna subtract half the first row away from the third row, and then we get -2, 1, -1, 0, 0.5, 0.5, and then 0, 0.5, 0.5. So then the third row we can subtract the second row away from the third row.
Okay.
And eliminate it to zeros.
Yeah.
So basically, and then if you want, we can multiply this just to get it to 0, 1, 1.
Okay.
So what this tells us is that we're gonna have three x's, x1, x2, x3. This bottom here tells us that x2 plus x3 equals 0, so x2 equals -x3.
All right.
So we make that 1 and -1. We can do it the other way. We can make x2 -1 if we wanted to, but it's the same vector.
But right in the
And then
the thing on the top.
x1. And then from here, we know that x1 is going to be, since this has to go to 0 too, and we have -2 x1 and -2 or plus 2 because plus 2 equals 0.
Yeah.
So x1 is 1.
X1 is 1 also.
And that's what we got down there.
Okay. Yeah, and that's the calculation for how you get
The second eigenvector.
That's how we get the second eigenvector. Okay, cool. So now what we're going to do is we're going to maybe we'll stay with this one and we'll do his calculation for computing the values of these eigenvectors in here from his formula. Here, what is the length of this vector?
It would be √3.
Yeah, √3. So we need to multiply it by 1 over √3 to make it a unit vector. That's fine. All right, so let's go to back to the formula, and then we'll have to also explain what the other matrix we have to consider is.
All right.